Hello and welcome. If you're new here, my name is Joe, and I rant about the things that I think we need to do to prepare for the coming effects of climate change. If you've been here before, welcome back. In this video, I'll be debunking natural causes of recent climate change. So one thing climate change deniers like to do is point out that the climate has changed back and forth, warm, cold, ice ages, warm periods. We've had all kinds of changes over the millions and billions of years. And yes, that's true. And we have figured out the cause of those changes. So I'm going to go through some astronomical cycles that explain some of the past heating and cooling trends that have happened on the Earth and show that that is not what is happening now, and that recent climate change, global warming, this is completely man-made. Okay, so there are 5 cycles I'm going to go through. These are referred to as the Milankovitch cycles. This was a scientist that worked on this decades ago. And what I'll be going through are something called orbital eccentricity. This refers to the roundness of an orbit. Not all orbits are, actually very few, if any orbits are perfectly round, they're more elliptical. So how elliptical they are, or how not round they are, refers to how eccentric they are. And that actually changes. So that's one cycle. Axial tilt. This is the reason why we have seasons. Sometimes the North Pole is tilted towards the sun, sometimes the South Pole is tilted towards the sun. The fact that it's tilted at all relative to our orbital plane, again, that's the reason we have seasons, but that tilt changes over time, so that's another cycle I'll show. Something called axial precession. So axial precession is the tilt itself doesn't just change over time by how much it's tilted, it also wobbles, kind of the way a spinning top wobbles. So that, for example, well, I'll get into this more in a few minutes, but and then something called apsidal precession. So when you have an ellipse as opposed to a circle has a center, but an ellipse has 2 focus points. And when you're talking about an orbit, the center of gravity is going to be at one of those focus points. So in this case, we're talking about the sun. So apsidal precession refers to the fact that one focus point orbits around the other. So you'll see what that means in just a minute. And then orbital inclination refers to the fact that the Earth's orbit has a slightly different tilt than the average orbital plane of the entire solar system, which is basically whatever the orbital plane of Jupiter is. So when we go around the sun, it's the plane that contains that orbit is tilted a little bit slightly off from Jupiter and the other planets. And that changes over time as well. So these are the Milankovitch cycles. Let's start with orbital eccentricity. So on the left you see a perfect circle. There's no eccentricity at all. If this was an orbit, the sun would be right in the middle. Something with high eccentricity, again, an ellipse has 2 focus points, so in this case the sun would be at the one on the left. If you would imagine another one, the same exact position over on the right, just equivalent distance from the center there. Those would be the 2 focus points. And most planets have an orbit that is very close to circular. There's some eccentricity that each one has. It's very small. Something with high eccentricity would be something like a comet. Something that comes in, zips around the sun, and then zooms back out again for decades or centuries before it comes back in. So it's highly, highly elliptical or highly eccentric. For the Earth, the cycle of the Earth's eccentricity, or changes in that, is about every 100,000 years it goes through a cycle. So basically what that means is sometimes the Earth's orbit is more circular than other times. And so there's a period when it's at its most circular and a period when it's at its most elliptical, and it's fluctuating back and forth between those. These are very, very, very minor changes, but what that does do is it impacts how close or how far away the sun is during the course of its orbit. So if it's a perfect circle, at all times, every year, every day of the year, I should say, we're getting the same exact amount of solar radiation based on our distance from the sun. But if it was elliptical, or more elliptical at times, then there would be periods when not only would the sun and Earth be closer than other periods of the year, but there would be a point where it would be at its closest, and another point where it's at its furthest away. So this will come up in another one of these cycles in just a minute. So again, the Earth's eccentricity cycle, we're actually going through a period right now. So again, it goes through a full cycle every 100,000 years. Right now, our eccentricity is actually decreasing. And what that would do to our climate is it should moderate it, because that means the fluctuations as to how far away and how close we get during the course of a year, those differences are smaller. So if we're not as far away as the extreme that sometimes our orbit has, and we're not as close as the extreme as our orbit sometimes has, basically if that eccentricity is shrinking, we're getting more circular, then our climate should be moderating, not getting more extreme. So based on this particular cycle, we should be entering a cooling period, but we're not. So this is how mankind's contribution to greenhouse gases into the atmosphere is actually going against the trend of what this particular cycle would otherwise be pointing towards, what we're heading into. All right, next is axial tilt. So right now the axis is tilted at about 23.5 degrees. It's 23.44 degrees. And this is the angle off of the perpendicular from our orbital plane. So anyway, again, this was what gives us the seasons. When the North Pole, for the Northern Hemisphere anyway, when the North Pole is tilted towards the sun, we call that summertime. When the North Pole is tilted away from the sun, then that is, we experience wintertime. But the tilt can vary anywhere from 22.1 degrees to as much as 24.5 degrees. And it goes through a full, complete cycle of back and forth between those every 41,000 years. When it is tilted more, that means that the polar latitudes are getting sun. Some latitudes are actually getting sun that those areas otherwise wouldn't even get at all during the wintertime. And they're having longer days in the summertime. But in the end, what it really means is more solar radiation for the polar regions during periods of increased tilt, and less total solar radiation for the equatorial regions. When the Earth is tilted less, then over the course of the year, the equator is absorbing more heat than when the poles are tilted more. So the equatorial regions would get warmer and the poles would get cooler. What that would tend to do is actually, this is one of the biggest causes. This is the primary driver, actually, or historically has been over the past 5 million years, the biggest driver of ice ages. In the last million years, it's actually switched from a 41,000 year cycle to a 100,000 year cycle. I'll go into that more in just a minute. But basically, when the Earth's axis is tilted less, in other words, the North Pole and South Pole are more straight up and down relative to our orbital plane, that is when the polar regions are getting less direct sunlight, less sunlight at all during the winter. They have longer winters. That means the Arctic Circle would actually be further southward. That's the line where on the first day of winter you do or don't even see the sun at all. If you don't see the sun, then you are above the Arctic Circle. So that would actually come further south. There'd be greater areas that don't get sunlight during the peak of winter, or I should say during the peak of darkness. And so anyway, right now what we are going through is our axis is actually standing up more. This axial tilt is decreasing. So we should actually be entering a period of cooling polar regions. But that is not what is happening. As the climate changes due to global warming, and again, it's called climate change because it's the change happening on a planetary scale is more than just warmth. That affects plant life, it affects precipitation, it affects all kinds of things. But it actually really is, the root cause is global warming. It is a warming of the planet that's causing climate change. But if the tilt is actually decreasing, we should be entering into an ice age over the coming thousands of years. We should be in a cooling pattern. We're not. The poles are actually the areas that are getting warmer the fastest. So this is yet another cycle where recent trends, and I'm talking about recent over the past just couple of 100 years, and in particular the last several decades, massively goes against the natural cycles of the past hundreds of thousands of years, if not millions of years actually. And it specifically goes against the trend we should be seeing based on the change in the current change in axial tilt. All right, next is axial precession. So the tilt of the axis, whatever angle it happens to be, goes through a wobble. So basically what that means is right now, on December 20th, 21st, it varies, 22nd, that is when the poles are aligned exactly with the Earth and the Sun. So in other words, the North Pole is tilted away from the Sun, the most it's going to be. The South Pole is tilted towards the Sun, the most it's going to be. We call that the first day of winter in the Northern Hemisphere. 13,000 years from now, however, on December 21st, because our orbit isn't getting any faster or slower, it's still going to be 365 and a quarter days every time around the Sun, but on December 21st, 13,000 years from now, the North Pole will be tilted towards the Sun. And then 13,000 years later, completing the cycle of 26,000 years, the North Pole is back to being tilted away from the Sun on December 21st. So 13,000 years from now, first day of summer will be in December for the Northern Hemisphere. This is because the Earth's axis wobbles back. It goes in the axis actually basically just goes in a circle once every 26,000 years. Next is apsidal precession. As I mentioned earlier, this is basically when you have two focus points, which an ellipse has, and the center of gravity is at one of those, then the other one is going to orbit around it. So what you end up with is the ellipse itself kind of does this wobble centered on one of those focus points, which in this case would be the Sun, if we're talking about the orbit of a planet. It has a cycle of about 112,000 years. And all this really does is impact the length of the cycle, I should say the length of the other cycles. In particular, this one I just showed here about axial precession, sometimes it actually speeds it up to a cycle of about 23,000 years, but it can vary anywhere from I think 21 to 28,000. But anyway, so apsidal precession just speeds that up a little bit. And it also has an impact of what it would do in the long term is just move the seasons forward. So the first day of spring would actually be in March, and then it would be in February, and then it would be in January. So anyway, it's very similar in terms of the time scale of some of these other cycles. This is 112,000 years versus 100,000. But this actually has no impact on our climate at all. This is just impacts the shape of our orbit relative to where it was sometime in the past, relative to the solar system. So anyway, the last one is orbital inclination. This one has a cycle of 100,000 years as well. And the main reason for this one having a 100,000 year cycle and a couple of others having nearly 100,000, the last one was 112, and the orbital eccentricity, where our orbit kind of goes from more round to less round to more round to less round. All of those are on the time scale of about 100,000 years because of the influence of Jupiter and Saturn. Apparently about every 100,000 years, where they are relative to the Earth. I mean, sometimes Jupiter and Saturn are on the same side as the Sun. They're near, they're on the same side of the solar system together. Sometimes they're on opposite sides of the solar system. The Earth is being pulled mostly by the Sun, but as Jupiter and Saturn pass behind us, away from the Sun, again, sometimes they're pulling us away from the Sun, sometimes they're pulling us closer towards the Sun. All depends on where they are relative to the Sun, relative to us. But it goes through a 100,000 year cycle that Jupiter and Saturn cause these other wobbles in our orbit. So the net effect of all of this is that, just to sum up these Milankovitch cycles, so orbital eccentricity, it's decreasing. And I have this word in blue because this indicates that it should be a cooling effect. Because right now, again, the eccentricity is decreasing means you're going into a more circular orbit, which would mean that the seasons would be less extreme. The axial tilt is decreasing, which means the polar regions should be cooling, but they're not. Axial precession, currently the South Pole is tilted towards the Sun. So I forgot to mention this earlier. So perihelion is when we are closest to the Sun. This was shown in one of the earlier slides, perihelion versus aphelion. And perihelion, if the South Pole is tilted towards the Sun while we are closest to the Sun, the Southern Hemisphere is mostly ocean. So the other impact of that is the by not having mostly landmass like the northern hemisphere has. Now, let me say that in reverse. 13,000 years from now, the North Pole will be facing towards the sun at perihelion, and what that means is the northern hemisphere, which is mostly landmass, will be closest to the sun at that period of time, and I don't know that we really know what that means. Will that mean more land to absorb heat that otherwise was being reflected by the oceans? But the other side of that means that if the northern hemisphere and all of our land masses, or most of them, are tilted towards the sun while we're closest to the sun, that means the southern hemisphere, mostly oceans, is now tilted away from the sun. Is getting less overall solar radiation throughout the year, and that should add up to more sea ice, which means that when they have when the sun is finally, or I should say when they approach summer down there should be less cooling that happens because of that, because there should be a lot more sea ice to reflect that sun out into space as opposed to the Earth having a chance to absorb it in the first place. So axial precession is probably netting out as not warming or cooling. We don't really know. I mean, we know the orbital eccentricity should cause cooling. Axial tilt should cause cooling. Axial precession, not sure. Apsidal precession probably has no impact. Orbital inclination also probably has no impact. If anything, all it does is add to or decrease the axial tilt, perhaps. So those are the cycles, and let's move on to some actual data here. So I know this graph is kind of busy. What you're looking at is what's called an ice core sample. This was taken from Antarctica, and this goes back 420,000 years. The tick marks at the bottom represent 10,000 years apiece. So the blue line at the top, that is concentration of carbon dioxide in the atmosphere. The way they measure this is they drill down into the ice and they remove a big cylinder of ice that the deeper you go into that ice, the longer ago that ice was created. And when ice is formed, it traps air bubbles. There are little pockets of air trapped inside the ice. So the deeper you drill into the ice and then test those air bubbles, and measure what they're made out of, what compounds, anything you can get out of that information when you measure what's going on inside those air bubbles, you can recreate the past. And so we can see here these different cycles in blue of carbon dioxide concentration in parts per million. This may be hard to see, but on the left, this varies from, it shows 200 to 280. But the zigzag in the line actually sometimes seems to drop as low as 180, if not lower, and at times seems to go above 300, if there was a 300 there, maybe even a little bit higher. But otherwise, the trend seems to be that every 100,000 years, it goes from around 180 to 280, 180 to 280, 180 to 280. And the red line underneath that is temperature change in degrees Celsius relative to recent time. So if you look at the axis on the far right, if you can read that, it goes as high as 2 degrees higher than recent our current era, and as low as 8 degrees cooler than our than our current or recent measurement of temperature on the planet. So there's quite a bit of a temperature range, and it is during these cooling periods that we have these ice ages. So you can see during the last peak, it was about 100,000 years ago, well, about 120,000 years ago, and then we entered a cooling phase, and during that phase, a lot of carbon dioxide was also removed from the atmosphere. I should point out that this range of 180 to 280 is interesting when you compare it to the fact that we are now currently over 400. It's now over 400 parts per million is the carbon dioxide concentration in our atmosphere today, which you can see has no historical precedence. This is a huge, huge change. So this Paris Accord that has pushed for no more than 2-degree increase over a baseline, I'm assuming this comes out of this historical record of naturally we do fluctuate as much as 2 degrees warmer and then as much as 8 degrees cooler. And if we go more than that, that's a sign of some serious trouble, because historically we just haven't done that. And in fact, whenever it has happened, it's been very brief, and then cooling comes on in. So if we look at the recent trends, if we follow this, I mean, this is kind of, let me explain time here at the bottom. 0 is at the bottom left, 420,000 years ago is at the bottom right. So if you go from left to right, you're going backwards in time. So if you go backwards in time just a little bit, you can see that we've been at the peak of warming and at the peak of carbon dioxide for a while now. It's time for us to be on our way down with both of those. And that's not what's happening. They are both going in the wrong direction. So this is why I say we're going completely against what otherwise would be the natural cycle. Let me move on to something else here. This is a quote I wanted to end with. We know that in the history of our Earth, there have been periods of warming and cooling, and it could depend on processes in the universe. A small change in the axis and the rotation of the Earth or its orbit around the Sun could push the planet into serious climate changes. Yes, these small changes do occur, but just because they have occurred doesn't mean that that's what's happening now. It doesn't explain this, Vladimir Putin. Why does Vladimir Putin want to be a climate change denier? The man's probably worth $200 billion. I'm sure he's the richest person on the planet if we were able to somehow measure his wealth. I mean, in Russia, everything is his. There's nothing he can't do, so wealth doesn't even have a meaning. But the point is, all that wealth is based on fossil fuels, natural gas and oil. And so because they have a lot of fossil fuels, because they have nuclear weapons, he can do all kinds of things that most world leaders would not be able to. But he is a huge climate change denier. And so basically anyone that is denying climate change is on the same page as Vladimir Putin. But this is what he's referring to, these small changes in the axis and its orbit and so forth. Yes, the Milankovitch cycles. This is true. So yes, there is historical precedent for the Earth warming. There is historical precedent for the Earth cooling. These cycles do exist. They're real. Climate change deniers pointing at them, though, not only is that wrong, if you actually look at the data, it's contradictory. Those cycles tell us that we should be getting cooler now, and we're not. So climate change and global warming is an even bigger deal than we have come to even begin to talk about on a wide-scale basis. So anyway, I'll wrap this one up here. If you have any comments or questions, please post them below. I hope you liked this video. If you did, please click like, and also please do subscribe. So thank you for watching, and I'll see you next time.